EnVision is a tool that allows you to remotely visualize and interact with 2D and 3D datasets. Here, I will give an example of this and show the visualization of two datasets. First, I browse to the location of the first dataset. This dataset, foot.raw.vtk, is a dataset that contains data on a 3D grid representation of a human foot. The first step in visualizing this human foot is to do a visualization and an algorithm of the outline of the domain of the dataset. If I apply an outline, I'll be able to see the bounds of the dataset and understand better how the foot fits into the big picture. Here you can see me manipulating the bounding box of the dataset. Now I'll apply a visualization algorithm called an isosurface. This will show a surface of a certain value of the foot. I'm going to use the default value that EnVision suggests, and I'm going to set the opacity to slightly less than 1 so that the surface is slightly transparent. After adding that algorithm, I can now see the skeletal structure of the human foot, all of which is contained within the bounding box. Zooming in, you can better see the image scans of the human foot. Now I would like to bring out the skin of the human foot and understand how the skeleton fits into the skin. I'll draw another isosurface at a different value this time. The value will be 48.25. I'll draw this at a low opacity so that we may still see the skeletal structure through the skin. The skin will require a large amount of computation and may take a slight amount of time. Here you can see the surface of the foot and still see and observe the skeletal structure within. As you can see, the rendering performance has dropped significantly, however, due to the large amounts of polygons in the rendering. If I delete that algorithm, I can get back the skeletal structure. Another useful algorithm for visualizing data is a cutting plane. Here I will do a cutting plane near the center of the dataset by dragging the slider towards the center. Using this cutting plane, I can see a slice of the data, and it's somewhat like a picture of the data. I can interactively change the location of the cutting plane at will. Cutting planes are useful when you begin to visualize data so that you can understand the range of values that are within the dataset. Having not used the cutting plane before, I would not have known the value that the skin was located at. However, I had done it before and I knew that the value must be slightly greater than the value of the skeleton. Now I'll open up a different dataset and do a different example visualization. The previous visualization had only a single variable, and that was density of the dataset. As you can see, I never selected any different variables. However, this dataset will have several different variables. This dataset is called Breaking Waves, and it represents a fluid dynamics simulation of water flow around the bow of a ship. I'll first plot a bounding box so that I can see the domain of the data. As we can see, it's an elongated rectangle. Next, I will do a cutting plane to see the range of values that the data may take. I'll do it normal to the y-axis and place the cutting plane near the center of the dataset and change the opacity to slightly less than 1. You can also color divide different variable. The previous dataset have only one variable, however this dataset has two. This time I will color by velocity. Here we can see a cutting plane or slice of the velocity variable through the center of the dataset. Next, I will apply an ISO surface to bring out a more interesting picture of the dataset. We'll use the default ISO value that EnVision presents, and we'll color by a different variable, opacity. And we'll set the opacity to slightly less than 1. Here you can clearly see the waves. Although the bow of the ship is not shown in this dataset, only the wave simulation is shown. You can see that the bow of the ship would be towards the front of your viewing angle, and the wave, the breaking wave, around the bow of the ship can be seen going diagonal through the dataset. Dark blue colors represent high velocity waves in motion, and turquoise and green colors represent low velocity waves in motion. As you can see, 3D visualizations of datasets allow you to gain insight into your data that you normally would not be able to make, and allows you to get an accurate picture of your dataset.